What's up, folks? Today I'm going to show you how to create a program, a simulation. Alright, so let's go ahead and start with a sphere. That's going to denote the location from which our light beam starts from. Alright, so there you go. There's our sphere. Not too bad. Of course, you can zoom in or out. So this sphere, we're going to call it P1. That's where our point starts. And let's call our second sphere point 2. That's where it's going to go. But we're not done just yet. We're going to give this sphere a position vector. So maybe -5, not 5, and we're going to give it a color, maybe green. So we're going to go ahead and take this position vector, make another one of this, and let's put that at 5. And so now you're going to see two green balls, right? One at -5, one at 5. Alright, good. One is the starting point, one's the ending point for a light beam. But wait, light beam, you say? Where is our light beam? Well, we're going to make it yellow, and we're going to make it pretty small, as a matter of fact, so that you don't see it for now, but you can see it when it moves. And to make it showing when it moves, to make sure you can see its trail, we're going to turn on the make trail. What else we've got? Well, we're going to put it at the position of the first point. And let's also make it ground. Why not? That's where our light is going to bounce off of. So let's say the box is, I don't know, its position is at 0, 0, 0, whatever. That's the origin. And let's say it has the size of, I'll say, 15, 0.5, 0.1. Okay, so that's the size of our box. Anything else? Did I miss anything? Alright, so property size must be a vector. Oh, I should write vector here. So here is our what we've got so far. Let's actually make our width a bit bigger so the thing can actually bounce off. Yeah, I shouldn't really make it that small. 15, 1, and 0.5, let's say. Oh, that's much better. Let's just make it 1. Alright, so here's what we got, right? Light's gonna bounce off from point 1, bounce off of this. Light's gonna emanate from point 1, bounce off of the slab, and go back to point 2. Alright, so how do we do this? Well, we gotta first check whether the light has hit that box. How do we check that? Well, we gotta check the Y position. So while the light's Y position is greater than 0, we're gonna say the light should be moving with some velocity that we're gonna denote as light dot velocity. What is that velocity? That velocity is gonna be the distance from where the light beam hits this slab. So let's call that the hit point. I'll also make that a sphere, as a matter of fact, and I'll say the hit point is at the same location as the ground. Okay, so let's say the light velocity is equal to the hit point minus hit point's position minus the point from which the light beam emanates position. And let's give some variables of time. So t is equal to 0, dt is equal to 0.05. For me, that usually works fine. And yeah, so let's go ahead and check this out. Let's see if it works. Alright, so light plus dot is not a function. So where did I put light plus dot? Line 19. Oh, sorry, yes, light dot position. Light dot pos. Oh, okay, wow, so very nice. So let's put a rate here. You're probably thinking, alright, what just happened? Well, I'll show you what happened. First of all, let me just reduce the size of this hit point. So that's okay. So now let's check out what happens. Well, you can see that happened pretty fast, so maybe I should slow it down. You can see how the light beam basically goes from the green point to the hit point. So maybe I should slow down my dt so that it goes a bit slower. Let's check it out now. And there you go, there's our light beam. And we'll make it 100 so the animation is crispy smooth. So here's our light beam, and boom, it didn't reflect yet because we didn't make that part of the code yet. So let me make the radius of this thing 0.7. Alright, so good. Now we're gonna make the reflecting part. So instead of saying while light position is greater than 0, that part is when it's moving from point 1 to the hit point. Now from the hit point to point 2. So how do we do that? Well, while light position dot x is less than the p2 dot position x, then first of all we're going to redefine the velocity function as p2 dot position minus hit point dot position, and then we're just going to say, yeah, just do the same thing again. So let's see if it works. Alright, so light comes here and light bounces. Yes, that's it, ladies and gentlemen, that is it.
Ambition plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.